Hello students and welcome back to week 6. Today we have 6.1. This week you only have 2 modules. We're going to keep it to 2 modules for the next 2 weeks as we close out eSchool. Today's objective is to calculate an element's protons, neutrons, and electrons using the periodic table. We started with a review of rounding, which we'll start with, and then we went back and looked at atomic models because today we're going to be actually using the periodic table instead of just looking at models of atoms. So let's dive in. To start, we're going to do some quick instruction on rounding and some rounding practice. So I'm going to go through some notes. I want you to summarize what you hear into your own words into these 2 steps here. And then we're going to get through the practice together. All right, so rounding is when you change a number with decimals into a whole number. We're always going to be rounding to the nearest whole number. Although sometimes in other classes you'll be asked to round to the tens place or the hundredths place, we're always going to round to the nearest whole number. So if the tens place, the one right after the decimal, is greater than or equal to 0.5, you're going to round it up to the next highest whole number. If it's less than 0.5, you're going to round down. Okay, summarize that in your own words. Let's go into practice. So 2.7, okay. Well, 2 is the number, we got our decimal, and then our tens place is 0.7. 0.7 is greater than 0.5, so we're going to round that up to 3. The next number, 1.25, well, find the tens place, 0.2, that's less than 0.5, so we're going to round down to 1. Next one, 15.87, 0.8, 8 is our tens place. That's going to round up to the next highest number, which is 16. And the last one, 21.092. Don't be tricked. Don't see that 9. That's not in the tens place. Find your tens place, which is 0.0. So that's less than 0.5. That's going to round down to 21. Go ahead and try the check for understanding yourself. When you're ready to resume the video, we'll go through the answer key together. All right, let's check our answer is 19.18, rounds down to 19. 27.384 rounds to 27. 10.9 is going to round up to 11. And 0.817 is going to round up to 1. Make sure you got all 4 of those correctly. If you need extra help, reach out to your teacher because you're going to need to understand how to be doing rounding for our lesson today. All right. We're going to dive into the meat of our lesson. So we're going to be learning how to read the periodic table and use this little square to calculate protons, neutrons, and electrons instead of needing an atomic model to do so. So just a quick review. Our atomic number is our whole number. Our element symbol is the 1 or 2 letter symbol, abbreviation. The element name is the full name. And the atomic mass is the number with some decimal points after it that's usually found below or on the bottom of the element square. So once again, I'm going to go through notes. I want you to summarize those into your own definitions. So, the atomic mass, the atomic number is always equal to the number of protons. Remember, a proton is what gives an atom its identity. So, this element square has lithium. The atomic number is 3, which means it has 3 protons. Every atom of lithium in the universe has 3 protons. That's what makes it lithium. So, let's look at what the atomic mass will tell us. Well, the atomic mass is the average mass of an atom of this element. So 6.941 is our average mass of lithium. Now, if you remember back when we first learned about atomic models, we said mass is equal to protons plus neutrons. Remember, electrons are so tiny that we don't even include their mass when doing the calculations. However, protons plus neutrons, that wouldn't give us a weird number with all these decimals. Now, that's because it's an average mass, and it's because we've averaged different isotopes, which I will not have time to cover this year, but you will definitely be able to cover in high school chemistry. So, what you need to know for today is we can use the atomic mass to calculate the number of neutrons. So first, we have to take the atomic mass and round it to the next nearest whole number. Then we subtract the number of protons, or the atomic number, and that gives us the number of neutrons. Finally, you might be asking, well, what about electrons? I don't see anything about electrons. Electrons in a neutral atom, so an atom that has a charge of 0, are always going to be equal to the number of protons. So if I have 3 positive protons and I have a charge of 0, that means I also have 3 negative electrons. So today, assuming the charge is going to be 0, electrons are also always going to be equal to the atomic number. Let's put that into our notes. Should have already filled out atomic number and atomic mass. Let's put down some steps. So for protons, it's equal to the number, to the atomic number. Neutrons, there's 2 steps. First, you need to round the atomic mass. And second, you need to do atomic mass minus the number of protons gives you the number of neutrons. And electrons will be equal to the number of protons in a neutral atom. And that's when our charge is 0. And once again, for today, our charge is always going to be 0. Okay, so you do not need to do any extra calculations there. Let's move on to our guided practice. If you need some extra time, go ahead and pause. All right, go ahead and click to open the link to the periodic table. When you do so, you will see a full periodic table like this one. We're going to answer questions for each of the following things. So first we have nitrogen. So we need to figure out the atomic symbol, the atomic number, the mass, how many protons, neutrons, and electrons it has. So on our periodic table, we have nitrogen here. It's the 7th element. I'm going to go ahead and zoom in to make it a little bit easier to see. So symbol is a capital N. Atomic number in the top left was 7. The atomic mass was 14.007, I believe. Yes, it was 14.007. How many protons does it have? Well, that's equal to my atomic number. So if I have an atomic number of 7, I have 7 protons. Neutrons, remember, this is when we need to do a calculation. First, I need to round 14.007, my atomic mass, to a whole number. So that's going to round down to 14. Then I'm going to subtract the number of protons, which is 7, and that gives me 7 neutrons. Finally, how many electrons does a neutral atom of nitrogen have? So neutral means its charge is 0. So if I have 7 protons, I'm also going to have 7 electrons. Now, you may note, wait, 7 protons, 7 neutrons, and 7 electrons. Is it always going to be the same? No, it's not. A lot of the smaller elements of the periodic table are going to have very similar protons, neutrons, and electrons. However, as you get to larger elements, you're all of a sudden going to see that the number of neutrons can be vastly different than the number of protons and electrons. Here's the same type of problem, just set up in a slightly different format. So we're going to fill out this whole chart. However, this time I didn't tell you which element it was. You're going to have to figure that out. So what information did I give you? In my first row, I told you the number of protons is 8. Well, that tells us important information. First, that tells us we're looking for the 8th element with an atomic number of 8, which I see right here. It is oxygen. Okay, so let's use this element square for oxygen to fill out the information. So, element name, oxygen, symbol is a capital O, atomic number is 8, atomic mass is 15.999, which will round to 16. We have 8 protons, so we must have 8 electrons in a neutral atom. And the number of neutrons, well, 16 is my rounded atomic mass, minus my number of protons, which is 8, gives me 8 neutrons as well. Once again, 8, 8, 8 for that one, but not always going to be the case. All right, next one. We have an atomic number of 2. So let's go back to our periodic table and try to find where an atomic number of 2 is located. I see it right here in the top right-hand corner for helium. Okay, so let's zoom in on helium and use this information. So, helium is the name, symbol is He, atomic number is 2, atomic mass is 4.003, which will round down to 4. Number of protons, well, number of protons is equal to my atomic number, which is 2, which means I'm also going to have 2 electrons, and then neutrons, 4 minus 2 gives me 2 neutrons as well. All right, Last type of practice problem you'll see today is number 3. This time it's going to give you a Bohr model, which we'll learn about tomorrow, but it gives you this atomic model, and it asks you to identify this element. Wait, but how am I supposed to do that? I don't know what that is. Well, remember, protons determine the identity of an element. So if we can count up the protons, we'll be able to figure out what the atomic number is, and therefore know what element it is. So we're working backwards now. So let's look at our nucleus where we're going to find our protons. We have yellow circles and we have blue circles with pluses in them. The blue circles are going to represent protons. Remember, protons are positive. So the person who made this model used that little plus symbol to represent it was a proton. So I have 1, 2, 3, 4 blue protons. So I have 4 protons. That means my atomic number is 4. Let's look at the periodic table and find the 4th element. It is here, beryllium. Number 4, that means that's the one we're looking for. So the element is beryllium, since it has 4 protons, which means its atomic number is 4. Wow, I cannot spell today. All right, go ahead and pause the video right here. Answer the check for understanding questions, and resume the video when you're ready to go through the answers together. All right, let's go through the answer key. First row is lithium. It gives you element symbol is Li, atomic number is 3, mass is 6.941, rounded, that is 7, which means we're going to have 3 protons, 3 electrons, and 4 neutrons. Remember, I told you sometimes the neutrons are going to be different. Great. Carbon, capital C, atomic number 6, 12.011, which rounds to 12, 6 protons, 6 electrons, 6 neutrons. All right. Number 2, on the right is a model of an atom. The element is nitrogen. I know that because it has 7 protons, which means its atomic number is 7. Give your score out of 15, and then you're ready to move on to independent practice to apply this learning, and make sure you take today's mastery check as well. See you next lesson.